Let us begin today's program with prayer. Reverend Vincent Robert, the co-director of Kanyakumari Diocese, will lead us in prayer. Vincent Ayya, please.
Yes. Yes. Can you hear me?
Yes, yes.
Let us pray. Creator God and Heavenly Father, thank you for this wonderful evening and the blessings which you have given in our lives. Lord, thank you for this universe and all the natural resources of the earth. Thank you, Lord, for the responsibilities which is given to us to protect the environment of this earth as our disciples. Lord, we give thanks for the commitment of climate change advocates who boldly challenge the status quo and give a voice to the voiceless all around the world who are actually suffering the effects of climate change right now. Lord, we pray for this webinar campaign for climate resilience. We pray for the Church of South India, Synod Ecological Concern Department, directors, and all the bishops and resource persons who are involving in and contributing in making awareness to the students and the congregations. Bless all the participants, resource persons, and organizers of this particular program. Lord, have mercy upon us, renew our strength, grant enough courage and wisdom so that we can be better stewards of the world we live in. Through Christ our Lord. Amen.
Thank you, Vincent Ayya. Good evening. I am Dr. Matthew Koshi-Punnekada, Honorary Director of CSI Synod Department of Ecological Concerns. Dear respected Bishop A.R. Chellaiah, today's speaker Mr. C. Jayaraman, clergy, teachers, and dear students. A warm welcome to all those who are participating in these Zoom lectures for the campaign for climate resilient churches, schools, and communities. We are arranging a series of lectures on Tuesdays through Zoom for the benefit of clergy, teachers, and students. These are orientation classes for building up climate resilient community. We have conducted 5 Zoom lectures so far. 2 lectures for clergy, 2 for teachers, and 1 for students. The students meeting held on 18th June, Dr. Sultan Ahmad Ismail addressed the students. Today's program is also for students. Bishop A.R. Chellaiah, the Bishop of CSI Kanyakumari Diocese, has agreed to inaugurate today's program. He finished his graduation from Scott Christian College in Nagarkoil and secured his MA in philosophy from Madurai University. He started his theological journey from TTS Madurai and did his MTH from United Theological College, Bengaluru. He has his doctorate in theology from Saramburth University. He was ordained as a presbyter in the CSI Kanyakumari Diocese in 1994. He became a bishop in 2019. He married to Mrs. Professor Felicia Chellaiah and blessed with a son and a daughter. Bishop, on behalf of CSI Synod Department of Ecological Concern, I cordially welcome you to this program. Today's speaker is Mr. C. Jayaraman. He is the co-founder and managing director of Equinaut, a community resource modeling solutions. He is the former senior manager, BPCL Kochi Refinery. Fulbright Kalam Doctor Research Affiliate and Lawrence Berkeley National Lab 2018 and 19. Fulbright Nehru Environmental Leadership Fellow in 2010. He will be delivering a lecture on energy and climate change today. He was with us on 22nd April for delivering keynote address on Of Earth Day. Sir, I welcome you to this program. I welcome all the participants to this program, especially a warm welcome to all the students. I have two announcements also. The participants can write their questions and clarifications in the chat box. Immediately after the vote of thanks, a link will appear in the chat box. Students have to click on the link to get questions for today's quiz. You will be directed to Google Sheets. Remember, only students will get cash awards. We will give you 7 minutes to answer. We will value it within next 5 minutes and results will be announced immediately. I cordially welcome Bishop A.R. Chelaya to inaugurate the program. Bishop, there is no light in front of you.
Yeah, light in front. There is no light in front of you. Good evening, all of you. In the name of Father, Son, and the Holy Spirit, I greet you all. It's a great privilege to participate in this program of energy and climate change. As our beloved Director of Ecological Concern, he mentioned the schedule of the program. A special word of thanks to the Department of Ecology Concern Honorary Director, Professor Dr. Matthew Goshi. He involved this Ministry of Ecological Concern in various capacities. Especially, he published a lot of books in this regard. On behalf of our diocese, Kanyakumari, I extend greetings to you also. Then I greet our beloved speaker of this day, Mr. Jairam. He is going to speak about the trend of energy and climate change, the current situation. On behalf of the diocese, I extend my greetings to the special speaker of this day. In our diocese, we don't have the special department of ecology, but we arrange for to coordinate all these programs, Reverend Vincent Robert. On behalf of the diocese, I greet you also, and I greet all the student community, the clergy, and those who are participate in this Zoom meeting. Very first, our beloved Professor mentioned me very briefly. There is no sermon, just you inaugurate the program. However, I could try to finish within 5 minutes in the inaugural program. Ecology concern is a very, very important one. In 1986, the word ecology used by Evans Kegel once that ecology concerns talk about in the Western countries. Now, in whole world, the ecological concern, ecological issues are taking very serious. But in the word ecology is a Greek word oikumene. Oikumene it means house or home. In Tamil, that is Vasudeva Kudumbakam. That means the world is a family, is a family of God. That's why we are talking about that ecology. The vision of the ecology or Vaikumane in CSI is very much related to our day-to-day life. As in the Synod considered is ecology is very much related to that day-to-day life of justice, peace, unity, and integrity of creation. In 1980s, the World Christian Council concerned about this one. They organized JPIC, Justice, Peace, Integrity of Creation. That much of interested in church and world level related to ecological concern. We never separate the ecological concern and our day-to-day life. In the biblical understanding of ecology, in early days, people thought that the nature is somewhat different or is considered as a material one. It's a what is it, a third person like that. But in the scripture, very clearly mentioned, as we all well known about Genesis 9, verses 11 and 12. After the flood of the time of Noah, God mentioned like that, I establish my covenant with you, that never again shall all flesh to be cut off the waters of the flood, and never again shall there be a flood to destroy the earth. God said, this is the sign of the covenant that I make between me and you and ever living creatures, that is with you for all future generations. Thus, we could get a very clear idea and inspiration. God concerned with not only human, but he concerned with whole creatures. That's why we are very much concerned about the ecological concern nowadays. I'm not going to preach a big sermon as a student community in front of me and other people, those who are very much involved in ecological issues and related. But my simple or my one word is grateful. Grateful towards God or gratitude towards God, towards fellow human being and the nature. The three things are God and human and nature is intertwined. We can't separate. If you separate, then there is a problem. That's a thing is happening. That's why my humble wish and expectation is everyone, each one, each day, we should be grateful to the creation of God, to the image of God of fellow human, and the what is it, the nature, because nature is always express God's glory and love. Without nature, we can't live. Thus, this situation, the Synod Ecological Concern Department, to promote awareness to the next generation of students, I expect and my wish is each one, each day, we should gratitude towards the nature and live according to God's will and God's expectation. Wish you all Amen.
Thank you, Bishop, for your inspiring words. I now call upon today's speaker, Mr. C. Jayaraman, to deliver the keynote address.
Good evening. Can you hear me?
Yes, yes.
Good evening.
Yes. Dr. Matthew, there was a request from someone whether I can explain it in Tamil.
No.
Sorry that, but let him, if he wants, he can
Five people, students from 5 states are attending, so we cannot do it in Tamil.
Yeah, I'm going to speak in English, but if they want to ask some questions in Tamil, probably some of you can translate that to me so that I can answer if they have any specific questions. And as I'm sorry that this is a heterogeneous group, so I may have to stick on to English. And if you find any difficulty, please stop and ask your questions. And my dear children, sit relaxed. Don't be so tensed. I can see so many faces sitting here. Relaxed. I'm not going to teach you so many difficult things here. We are just going to discuss something. We are jointly trying to understand. And probably if you ask some questions, then it will be a learning for me also. So whenever you want, you can unmute and ask questions if the organizers permit that. I think it's okay. Yeah, thank you. Relaxed. We are just going to understand our Earth. We are going to understand ourselves. And I'm just talking to you something about energy and climate change in between. So let me share my screen. Can you see my screen?
Yes.
And if you find any difficulty in viewing this, or if by any chance the screens are not moving, or if you cannot hear me, I hope one of the coordinators will alert me so that I will not be able to see the entire group here when I'm making a presentation. Okay. So as the title says, it is we are going to discuss, or we are going to understand something about energy and climate change. Before moving into that, I'm sure that you all know a couple of days back on June 5th, we celebrated World Environment Day. And the theme for that World Environment Day was ecosystem restoration. This time, it is really important. The UN said that this is not going to be celebrated on one single day. And that's why they said that it is from 2021 to 2030, 1 decade that we are going to talk about that ecosystem restoration. That is why it's so important. So when you learn about ecosystems, I think we may have to learn about anything like energy, environment, climate, water, ocean, river, rain, humidity, and probably a little bit about human beings and other animals. But all these things are equally important when you're talking about an ecosystem. And when we are going to discuss this for the next 1 decade, because this is going to be a very, very important theme for all of you. I think someone is using their annotation. Whether the organizers can.
Ebenezer, kindly. Ebenezer.
I don't know how to.
Ebenezer. Some students are doing.
No, it might be my mistake that they might have touched that annotation pen. But the problem is the slides will not be visible to others if you're doing those things. It looks beautiful.
Students kindly avoid doing like that.
How can you remove these annotations? What is already there? Only that person can do? I'm not very sure.
It's okay.
Okay. Yeah. Those who are by mistake that use that annotation pen, please erase those things. And I'm also, I know you all know the importance of this day, that June 8th. Today is the World Oceans Day. And I'll be talking a little bit about oceans also when I'm talking about energy and climate change and ecosystems and all those things. I would like to introduce to you two terms. Don't get very much upset by this very tough words like anthropocentrism. Just understand these two words because you are going to listen to these, or you are going to listen to these words in the coming years from every corner of the world, where anthropocentrism is about the belief that human beings are the most important entity in the universe. That means some of us believe that we are the most important entity in this world. There are many other creatures around us. There are many. That is why when I started talking about ecosystems, it is human beings came the last in my list. There are many other things, but some of us still believe that we are the most important entity in the universe. And there is another word called Anthropocene. People believe that we are living in this world in a period of Anthropocene, where actions that are created by human beings have impacted the Earth's geology and ecosystems, including but not limited to the climate change. We have listened to climate change, but there are many, many things that because of our actions, the human beings' action, the world, there's a great impact on our Earth. So just understand these or keep somewhere in your corner of your mind these two words like anthropocentrism and Anthropocene. They are very important. So I don't get afraid by this photo. It's our forefather, or probably as Daniel Quinn said, he's our neighbor. And he's asking a very ridiculous question. Without gorilla, will there be hope for man? What a question, no? Do you think that without gorilla, something will happen to man? It seems very ridiculous, no? We have seen gorillas only in the zoos sometimes. We don't know how many of them are still there, but this gorilla is very special. This is from a book called Ishmael, written by Daniel Quinn. This gorilla can speak, like I can speak, you can speak, he can speak. And he was discussing with a man about the future of, and he asked this question: without gorilla, will there be hope for man? I'm not going to the details of that book because it will take quite a lot of time to dwell on that. But I am going to ask you one question. Without human beings, will there be hope for the earth? Do you think if human beings are not there, whether something will happen to the earth? Or are we so important for the earth? So this is similar to what the gorilla is asking. Without me, whether you can survive? And we are asking the earth, without us, oh earth, can you survive? Why? You might be wondering why I'm talking about these things when I'm supposed to talk about energy and climate change. But I told you, just relax. There are certain things that we have to think, we have to understand that we are not the only creature on this earth. So I'll ask you, if some of you can unmute and answer this question, what is the unique feature that made this human being superior to other animals? I think many of you believe that we are superior to many other animals. Can any one of you unmute and say, what is this unique feature that makes this human being superior? Sorry. Anyone? Just unmute and say, do you think that we are unique, we are superior to other animals? Anybody? I can't see most of your faces, so I don't want to call your name. Anybody like Sid Krishna or Jia or Shiva, anybody can answer. Do you believe that human beings are superior to other animals? No, you find it difficult to unmute?
Sir, we can communicate
because of our intelligence and
Very
we
good,
can
very good.
communicate, we can learn new things, and we can share our thoughts.
So
Yes,
you mean, yeah, okay. I got so many answers that we can communicate, we are intelligent, we can learn many things. Do you think no other animals can do that? Do you believe that they cannot communicate? Have you ever watched the ants moving on your floor? If you touch one ant, do you think he goes to every ant and say that there is a person here sitting and he's very dangerous, don't go that way, let us go in the other way around? Have you, if you observe any animal, they communicate with each other. We don't, that is not a very unique skill of human beings. Every animal in this, or every living creature can communicate from one to another. For example, how do the flowers communicate to bees? They don't use words, no? But still they communicate. Oh, hey, I am here. I'm a flower here. You, A, B, you come here and just take your food. So, and they also, all these animals think, no, if you have some pets in your house, like dogs or cats, you know that they are very, very intelligent. Sometimes they are more intelligent than us. Anything else that is unique? I'm not talking about the general.
Human beings can distinguish between what is right and wrong.
What is right and wrong? I'm very sorry that I still can't understand what is right and wrong, because sometimes when what I say right, you will say, no, it's wrong. When I say that keep quiet, this is a class, you have to listen to me. I can say that I'm right, but at the same time as a student, you will say, sir, you are wrong. I'm a student and I can ask questions. Right and wrong itself is very difficult, but and even if I'll share with you one example. Last week, I saw a WhatsApp message somewhere near Tamil Nadu on the borders of Kerala. A group of elephants came and damaged a big banana, what is it, that a lot of banana trees were there and they destroyed it. Yeah, and left only one of them. Just one of them they left and went off. And when people went and saw that there were some eggs and a bird's shell was there, and they were very, very conscious that they cannot destroy these things. So they know what is right and what is wrong. And you can cite hundreds of examples. If you go to a predator-oriented forest, you can see that the tiger or the lion will not attack a pregnant deer. They know it is wrong because it is food for the next generation. Many animals can do, and in that sense, right and wrong is sometimes often done better than human beings. Many of the animals do that.
Compassion for others.
Compassion, that's exactly what I said when I talked about the elephants. They had that compassion for that birds, which has not yet come to the world, and they did not destroy it. And if you walk around, you know how many of you can just walk out of your house in the middle of the night without any fear. If the human beings have that compassion, if all of us have that compassion, probably we can debate this on and on and on. And I can say that many of the things that you might see, if you really watch very cautiously, very carefully, if you watch them, you know that many of these things animals also have, and they are not unique to the human beings. But I can tell you there is one thing that is very unique to the human beings. Before that, I want to show you some of them. When you talk about we are superior animals, I just want to share you some examples where some of the other creatures are also superior than us. You can see this photograph, no? There's an eggshell, and probably someone like me is sitting inside when I was very young. Can you see this? Can you see this slide with an eggshell? Yeah,
Yes,
fine.
sir.
Thank you.
Yes, sir.
And it's said that eggshell is stronger than cement, weight by weight. If you test the strength of an eggshell, science have proved that it is stronger than cement. But we believe that cement is a very, very strong material by which we can build Burj Khalifas of 100+ floors, and our house is built with cement. And we believe that cement is very strong, but the science says that eggshell is stronger than cement. If you want to make cement, you have to add a lot of heat to it, lot of material, adding this, mixing it, and it is a very big process, especially adding a lot of heat into it. But when a henna makes an eggshell, It is a very simple process for them, but still it can make something that is better than what human beings have made, called cement. Another example is you can go to the YouTube and search cobweb is stronger than steel, and you can see hundreds of experiments carried out which prove that a cobweb that you can see around your house all the time is stronger than steel weight by weight. If you have that much of 1 gram of cobweb and 1 gram of steel, if you can make a wire out of it, the cobweb is at least 2 to 5 times stronger than steel. So there are some creatures who can make things that is much stronger than what human beings have so far invented or discovered. And this is something that you would like to love to see. I can see many faces, somebody running out of it, seeing the photograph of a cockroach. We are so much afraid. We are very superior animals, but I think many of us are really afraid of cockroaches. And cockroaches are very strong. You are not, but sometimes I am. When a cockroach just flies and sit on my face, I just make a sound, because I'm afraid. But these cockroaches are very strong. They have overcome many mass extinction, even in the history thus far. Human beings came to this world very recently. But I think many bacteria or many of these small creatures like cockroaches or even the mosquitoes came much, much before us. So, and they have survived all these catastrophes. And if I talked about bees and the flowers, and this flower has actually communicated to the bee, hey, come here, I have some honey, you take this and take. And it says that if all the bees went extinct, it would destroy the delicate balance of the Earth's ecosystem that affect the global food supplies. If bees get extinct, the Earth will not survive. But if the human beings get extinct, probably nothing will happen to this global Earth. And that is why Julie Gray, a scientist from University of Sheffield, said that even with our extraordinary capacity for innovation, adaptability, and many other things, human beings will not survive if we continue to act like this as we all do now. If the global warming continues in this fashion, probably human beings won't last in the coming a few decades after this. And one feature, I can tell you, the unique feature that human beings have is that no other animals can convert energy from one form to another to improve their living comfort. Elephants are very strong, lions are very strong, or elephants can pull big logs. They have got very much energy in them, but they cannot convert this energy to make their life comfortable. I am sitting in my house with lights on top of my head and fan revolving, converting energy that is generated quite 300, 400 miles from my house. And I'm converting that energy from one form to another form, and then improving my living comfort. This is something very, very unique to human beings. And that is why I am here today to speak to you about the importance of energy, because we are the people who can do this. And just because we are doing this, the Earth is now under threat. So what is energy?
The capacity to do a work.
Wow, wonderful. I know that you know all these answers. Energy is the capacity to do the work. It is one of the simplest form, no? So we know energy, and there is another many theories that we have learned about energy. And there is a theory called law of conservation of energy. You know that.
Ability to do work.
Yeah, it is the ability to do the work. It is the capacity to do the work. Very simple. Energy, it's very simple to understand. But the problem is, even though it's very simple, many people doesn't understand these things. So I'll just give you some fundamentals that you might have studied in your schools, but I just want to classify this energy so that we can understand it better. There is something called a microscopic forms of energy, which is related to the motion or the influence of external factors such as gravity. Like if something is moving, we call it as kinetic energy. If something is kept at a height of, say, 5 meters, 10 meters above our head, we say that, oh, it has got a potential energy. Or something, sometimes we call there is a magnetism in certain materials. There is something called electricity. All these are macroscopic forms of energy, which is actually related to the environment where it belongs. Because if you want to talk about kinetic energy, you have to say that with respect to this, this car is moving at 80 kilometers per hour, and the other car is moving at 60 kilometers per hour with respect to the earth, or something like that. And there is a microscopic energy, which is the molecular structure of the every molecule, every atom, everything. They have got an internal energy, which is called which can be called as chemical energy. When you eat food, we say that there is a chemical energy in that food, and that is a microscopic form of energy. Just to make you understand that, and whenever you want to understand any scientific terms, it is always better to understand how they are classified. So when somebody is asking about energy, why I'm doing this is, quite often when I'm talking about energy to many people, they think that energy means electricity. And if I talk about conserving energy, they say that, okay, switch off lights and fans. It is not just, energy is not just like electricity. Energy is not just, or energy conservation is not just switching off lights and fans. That is why I'm just going a little bit deeper into this classification. And this, you know this law, no? The first law of thermodynamics, called the law of energy conservation. You have studied this, no? Yeah. Energy, which states that although energy can change form, it can neither be created or destroyed. So I have a question. I'm talking about conservation of energy or something like that. When you cannot destroy, or when you cannot create energy, why should you conserve it? What is the purpose?
You can change energy into a different form, which is not good for us, which will not be that good for us.
Okay, why it is not good for us when we change energy from one form to another? Only that I can sit here under the fan, no? Because in the Idukki Dam in Kerala, it's around 200 miles from here, water is falling from a height, and they convert that to electricity, one form to another. That is a potential energy to electrical energy, and bringing it to my house, and that electricity is converted into mechanical energy to rotate the fan. So what is wrong in it? I'm actually improving my comfort, no? When we what you said is right, but I'm just asking you to get a little bit clarification.
It could give negative effect to our planet. It will result.
Negative effect in what way? I'm very sorry how I cannot see your faces when I'm presenting. So, but still, what is a negative effect you mean?
So for example, when we use air conditioning to increase our comfort,
yeah,
we are releasing chlorofluorocarbon, I believe, into the atmosphere, which might not be good for us.
Yeah, Shivani, there is some point in it, but nowadays, if you go to any air conditioning buying shop and ask them, they will say it is free from chlorofluorocarbons, because the compressor, the gas inside that is used inside the compressor nowadays is not this chlorofluorocarbons. And we have actually, the whole world has worked together to remove this CFCs, chlorofluorocarbons, from the world, because it is found to be very dangerous. But there is some point that what you're going to say is, whenever you're working an air conditioner in your house, it takes air from inside the house, cool it, and throw the hot air outside. Am I right?
Yes,
if you walk, if you see the air outside, there will be hot air coming outside. So in that way, actually, you're actually heating the earth. That way, what you said is somewhat right. It is not just the chlorofluorocarbons, but we can go to it in a deeper way. But I appreciate that. Thank you very much for that answer. Anybody can say, what is the problem? Why we have to conserve energy when we cannot destroy or create energy? You have learned about in the schools, no, conservation of energy and many other things. And you should ask these questions to the teachers. Teacher, why don't, one example, when the father started here with praying to God, and you cannot actually create God, or you cannot actually destroy God. We never talk about conserving God or conserving belief. Similar to that, but there's a point in this. I'll come to that in the next slide to make you clearly understand. Just see this, oh, lovely, smiling face, no? That's a girl from maybe somewhere from the corners of Africa, where this girl would have walked kilometers and kilometers every day to fetch this water for her house. And you can see this. And I just say that she is carrying a 10-liter water can here. And on the right side, you can see that there is a bucket into which she has poured this water. And by the time she walked into her house and reached there, and when she poured into that bucket, it had only 9 liters of water. It might have spilled, as I show in the. So this 10 liter, I can say that, okay, call it as an energy. She had 10 liters of water, or she can equivalent 10 liters of energy, if you can say. And when it reached her house, she had only 9 liters of water. You just learned this new term called exergy. This you might not learn in your textbooks, but just take this word exergy, and I'll explain this what exergy is. And there is another term, and by that, as I said, where this 1 liter has gone, this 1 liter has spilled on the floor. So the law of conservation of energy says that energy cannot be created or destroyed. Here I'm applying this analogy here. What is the total amount of water in that house? 9 liter in bucket and 1 liter on the floor. Am I right?
Yes, sir. Yes, sir.
So she brought 10 liters of water.
Yes, sir.
And there is 10 liter of water in the house, but she can drink only 9 liters of water, and that 1 liter is on the floor, which you cannot use. It is of very poor quality because it has spilled on the floor. Even though the quantity of water remains the same, its quality is not the same, because that 9 liter is a good quality water and 1 liter is not. And that is a new term called entropy that you will learn later when you are going to higher studies. But if you can understand, if you go to the textbooks of engineering and ask what is entropy, you will not understand the definition. It talks about randomness and many other things. But entropy is just the quality of energy. And what you said is right. When you convert energy from one form to another, actually you spill a little bit of energy on the floor, or you have some energy which is of very low quality. Here, there is 1 liter of water. Similar to that, every transformation of energy from one form to another, you lose a little bit of energy, which is of very poor quality. The quantity remains the same. If the law of conservation of energy is true here, because the total amount of water is 10 liters. Similarly, whatever conversion that you do, the total quantity remains the same. So you just understand these 3 words called energy, exergy, and entropy. Exergy is the actual useful quantity, like the 9 liter of water in the bucket. And entropy is the energy that is unavailable for direct conversion. Actually, you cannot convert one form to another. For example, you have air in your room. No? This air has got a lot of energy, but you cannot do any work with this energy. You defined energy as the capacity to do the work. So there are many forms of energy which is of very low quality or very high entropy, which you cannot use. And your answer was absolutely right when you said that when you convert one form to another, you are actually destroying the universe, because the entropy is increasing. Either it can be a low heat temperature, low, or anything, even the sound, what I'm making now. When I'm talking to you, I make a lot of noise. I make a lot of sound. This sound is also energy, but you cannot do any work with this my sound energy, or it is very difficult to do. I'm not saying you cannot, but it is very difficult. So understand that energy has got one is, when you're talking about the law of conservation of energy or the first law of thermodynamics, it is about the quantity of energy and not quality of energy. I think there is some crosstalks.
Jayaraman, can you please explain this with the air conditioner example?
Yeah. Thank you, Madhu. Yeah, and one of the students said about the air conditioner. No, when you operate an air conditioner to cool your room, what is that? You are using electricity to run that air conditioner. And when the efficiency, you say that, for example, you say that the air conditioner has got 80% efficiency. So the air conditioner does an 80% job inside the room to cool your room, and the 20% is actually wasted, or that is the heat that is going out from your house. And when that heat is pumped out of the room, that heat you cannot take back and do some work. So if you talk about the total energy, the heat that is going out of the air conditioner plus that heat that you have removed from the room, is the total energy remains the same, but the quality of energy that is pumped out of your room, or as the low grade heat energy, you cannot reuse. And as you convert any energy from one form to another form, there is a lot of these types of low quality, low grade energy is created, or the entropy is increasing. And as the entropy or the low grade energy is increasing, that creates a problem, as you rightly said, to the universe, whenever you convert one form to another. Your answer is absolutely right, but I just wanted to tell you or explain to you that why you have to conserve energy is that it is about increasing the efficiency of conversion from one form to another. Suppose I'm using an air conditioner with 80% efficiency. That means 20% is lost as entropy. If I'm using an air conditioner with 90% efficiency, only 10% is lost. So our job is to see that we use equipments that is having the highest efficiency point. Am I clear? Madhu, is it okay?
Sir.
Yes, sir.
Yeah.
Yes,
Thank you.
yes.
Yeah. And you keep on, as one of the participants says, you also ask these questions. Sir, can you please explain this with this? And Shivani gave a very good example of air conditioner when we were talking about that. So,
and I think you can also talk about what is meant by efficiency.
Yeah, okay. I think you know efficiency is that it is the ratio between output and input. If you give the same output from an input, you are getting 100% efficiency. But if your output is lesser than your input, then your efficiency is less than 100%. That is what I said. You have 10 liters of water, and ultimately what she got is only 9 liters of water in her house. That means she lost 1 liter or 10% of that water. So efficiency of that little girl in bringing water from the well to the house is, we can say that 90%, because she could bring only 9 liters to the bucket. 10 liter got spilled. So that is efficiency. The input is 10 liters, output is 9 liters. So 9 by 10 is into 100, that is 90% is the efficiency. Is it clear?
Yes, sir.
Okay,
Yes,
thank
sir.
you. Yeah. So, okay, I'm
Yes,
going to
sir.
show a picture here. Who is this? Have you ever seen this guy? You will not have, because I can give you a clue. He came. Pardon?
Sir,
Yeah.
can you show me the last picture once more?
Vasco da Gama.
Vasco da Gama.
Yeah, exactly. This last picture means the previous one.
Yes, sir.
This one. This one.
Yes, sir. Thank you, sir.
Okay. Yeah. And this is Vasco da Gama. Yeah, exactly. And
Thank you, sir.
I am from Calicut. I've been living in Ernakulam for a long time, but I belong to Calicut. And this person came to Calicut in 1498 using that ship that you can see on the back side. What is that energy that drove that ship all the way to Kapad beach in Kerala?
Wind energy.
Wind energy, tidal energy,
Tidal energy.
kinetic
Steam energy, sir.
Yeah.
Steam
You can
energy.
say- Steam was not there at all at that time.
Energy may be used.
It was 1498. I think steam engine came very, very after, maybe 200 years after that. It's right, wind energy and tidal energy. And you can also call it as a solar energy, because only because of sun this wind and tidal energy is created. You can say it's a solar ship. long back, Vasco da Gama came to Kerala using solar energy. That is, you are right. It's not steam. So what I'm going to do now next is just to introduce to you some forms of energy, that is, or the sources of energy, which is familiar to us, or listed by the World Energy Council. These are the 12 important sources of energy listed by World Energy Council. Coal. Coal has got different types like coking coal, bituminous coal, lignite. Then oil shale is a form of energy that came very recently. Natural gas, you know, I think you must have seen that compressed natural gas pipelines running all across the country, or the liquid natural gas. Then crude oil. I worked in a refinery where we process this crude oil to many things called LPG, petrol, diesel, aviation fuel, pet coke, and naphtha, and many other things. And there is something called biofuels, like we can use from biomass and convert that into fuels. And you must have heard people talking about waste to energy project by municipality. If anybody is from Ernakulam, you must have heard about the Brahmapuram plant, where they were trying to convert waste to energy. Then hydroelectricity, yes, you know about the dams where we convert. And geothermal, the hot springs that is coming out of the earth. Solar energy, wind energy, tide energy, and nuclear energy. These are the most important 12 forms of energy. And I'm just trying to classify this according to the textbooks, where in the old textbooks, this was classified, some of them were classified as conventional and some as non-conventional. I think you must have seen this, no? This type of classification. Is it still there in your textbook, that energy are converted, classified as conventional and non-conventional?
Yes, sir.
Yes.
Yes, sir.
So I have one question to you. There are 12 energy forms on the right side, but I have classified only 10. 2 of them are missing. 2 of them are missing, that is nuclear and shale oil. Where will you put this? Will you put this in conventional or unconventional? Before that, let me ask one question. You said that Vasco da Gama came here using solar energy, no? Or wind energy or tidal energy. And we have some noise. Okay. I think when you're trying to answer that question, some noise coming, it's okay. And I have put this in non-conventional energy according to the textbooks, which says that solar, wind, tide, biofuel, waste, geothermal, all are non-conventional. But we have seen almost 300 years back, one person came here using solar energy or wind energy or tidal energy. So absolutely, this is not the right way to classify, because it is not non-conventional. It is really conventional. Man has been using this energy right from his birth, solar energy. So it's the most conventional form of energy, but still, when textbook says that it is non-conventional, we have to ask them, why? When the teacher says, you have to ask the teacher, say, teacher, there is something wrong in that. It cannot be. So my problem was, I cannot put nuclear under conventional, because it started only very recently. I cannot put it under non-conventional also, because the practice is here that it will not gel with the other things that is there. And shale oil, also the same problem. If I put nuclear and shale oil under non-conventional, then there will be some confusion. So to avoid this confusion, earlier, a few decades back, India had got a ministry called Ministry of Non-Conventional Energy Sources. It was called MNES, but later they renamed as MNRE, Ministry of New and Renewable Energy, because there is no sense in saying that one is conventional and non-conventional, because you cannot accept one just because it is conventional, or you cannot reject because it is non-conventional. That is why we have classified energy into 2 groups called renewable and non-renewable. Now it makes sense, no? Because when it is non-renewable, you know that it is not going to be there for a long time. If it is renewable, okay, you can have it. You can count it like anything that you have. You have a sweet shop, you own a sweet shop where you can go and pick a sweet every day. Nobody is going to ask you. It is a renewable source for you. But if it is somebody and you have to pay that or if it is not going to be there for a long time, then you have to use it very carefully. Okay, if I pick all the sweets from the shop today, tomorrow I will not have anything to eat. No, so we will very carefully use. So that is why non-renewable sources like coal, natural gas, oil, nuclear, shale oil, or geothermal are going to extinct in the coming future. This shows that coal will last for around 300 years, maybe 350 years. Natural gas and oil will be there for another 30, 40 years. So by the time you all become of my age, you will not have this natural gas or oil in the world. Nuclear, we don't know how much it will last, but still it is not a renewable source. It will also get extinct. Shale oil and geothermal. Geothermal, in some of the textbooks, you will see that it is classified as renewable. But to be very frank, geothermal is also like any other natural sources. It is non-renewable. It will get extinct if you start using it in a very large way. So renewables are something that is renewable every year. Its stock get replenished, like hydro or solar energy is not going to get extinct, like the wind or tide or biofuel. So this is a better way of classifying energy, like renewable and non-renewable. And that is why we have a ministry called Ministry of New and Renewable Energy. So I have a problem even with this, because all those renewables are not sustainable. Sustainable means, which is, you know about, some of you might have studied about sustainable development. Some of you might have learned about the Brundtland Commission's report, which is that whatever that you use it with a purpose that it exists for the other generation also. For example, if I am using some of my resources, I should see that my children also should get it. I should not totally exhaust that resource. That is called sustainability. So I'm giving you a little bit of examples of some of the renewable forms. Now, some of the energy forms, that hydroelectricity is a renewable one. And whenever we are talking about in the climate change scenario, we say that we want a renewable energy sources. But hydroelectricity is viable. It is bearable. Cost is less. But the problem is it is not available everywhere. It is available only in certain pockets of the world. But it is not environment friendly, because whenever you want to build a dam, whenever you to convert energy, that potential energy to electricity energy, it creates a lot of problem to the ecosystems. And also there is another, some study says that the methane gas is emitted from the catchment area of the hydroelectric plants, which is also a greenhouse gas and creates a lot of climate change problems. I'm not going to that now. And coal and natural gas, the problem is whenever you burn coal or natural gas, since it contains carbon and hydrogen, it emits lots of carbon dioxide. And this carbon dioxide is one reason for the heating up of the earth. So even though it is viable, bearable, it is not an environment friendly source. And similar with nuclear energy, it has got a very high potential. Even with a small, a little bit of nuclear, you can produce a lot of energy, but still we don't know how it can be disposed. And there is a lot of radiation problems and the cost is very high. So even though some of the energy forms we know we have, it is not sustainable for the next generation. So we have to find out which is the best source. And there is no single answer, this is the best every time. But we have to learn about the good pros and cons, good and bad about all these energy sources. So I just told you about the sustainable development, just not going to the details, but just showing you a picture says that sustainability is about, there are three pillars called social, environment, and economic. That is, it should be a benefit for the society, it should be benefit for the environment, and it should be economically viable. So only when these three things come together, you will have sustainability. It should be bearable. That means the cost should be less. It should be equitable. That means it should be available to everybody, like the sunlight. You know, petroleum products, India is importing around 80% of petroleum products from Gulf countries. We don't have enough sources. So it should be viable. The cost should also be, only when these three things, when it is cheaper, we can call it as a sustainable energy. So with this, I'll just move on to a little bit on energy and ecosystems. I don't have a watch with me. So what is the time now? Just take a break.
7:30.
7:30.
29.
Oh, fine. So I can go up to 8 o'clock, no? Any questions in this so far? Just take a small break before going to the ecosystems. What I am trying to tell you is that first is energy means it is not just electricity alone. It's about, there are a lot of different types of energy. And when we convert energy from one form to another, some form of energy is converted into a low quality energy. And as the low quality energy increases, it creates some kind of disturbance into the ecosystems, like heat or anything. And we have to conserve energy means we have to convert it in the most possible way. So let's go to the next slide about how it is connected to the ecosystems. So there are, you can see this graph. The problem is, on the bottom, sorry, there's a green line going up and down from 800,000 years back, which is the atmospheric carbon dioxide. It is a measure of carbon dioxide in the atmosphere. It was going up from 200 to 250 ppm, parts per million. Almost, it goes up sometimes, comes down. But after that, on the right end of the graph, you can see by around 1950s, this has just gone up like an arrow in a very exponential way in 1950 level. And it has reached around 405 ppm by 2015-16. And in 2021, this year, April, the carbon dioxide amount in the atmosphere was recorded as 419 ppm. I'll tell you the importance of this. ppm is particles per million. Why we have to talk about carbon? I told you that we cannot use coal and natural gas because whenever you burn coal or natural gas, it produces carbon dioxide. And that is why whenever we converted energy to produce electricity or to run our vehicles, like using petrol or gas, or to produce electricity, we have emitted a lot of carbon dioxide in the atmosphere. In the last 50 or 70 years, this amount of carbon dioxide in the atmosphere has gone up like anything. It has reached 419.05 ppm in April 2021. If this grows, this is another graph which shows that the average difference in temperatures in every January. Every January they measured the temperature of the ocean and surface, and the departure from the average. That means you say that there's an average global temperature we have measured, and every January they try to measure this with the difference. And the first 1880 to maybe 1940, the temperature was going less than zero. That means there is no heating. It's from the average. But after 1940 and all, you can see some red graphs going up, maroon graphs. And after 1980, it is always going up and up and up and up. And by 2020, it has reached such a position that the January 2020 global land and ocean surface temperature was the highest in the history. Simply, if I can make it so simple, that it means that the global temperature, the average temperature of the Earth has gone up by around 1.1 degrees centigrade by 2020. And you might wonder, what is this 1 degree centigrade difference? No? But 1 degree centigrade can make a lot of difference. Just think about an ice. If you just bring your ice from your refrigerator and keep it outside on your dining table, with a little bit of increase in temperature, it melts and becomes water. No? So there are many, many other things that can happen when just 1 degree of centigrade of increase in the global average temperature. And we are actually, and one reason for this is said as, and these are some of the impacts of this 1 degree of increase in temperature. Jammu and Kashmir had a flood in 2014. Chennai had a big flood in 2015. Then Mumbai and Kerala and many other places had some floods in 2018 and 19. In Uttarakhand, there was a big forest fire in 2018. Last year in 2020, there was a cyclone called Amphan in India. And people say, or the climatologists or the scientists say, that all these things are happening because of this change in our climate, or because of this 1 degree centigrade rise in our global average temperature. So that is the impact. If you go to the list of something that happened in India from 2004 to 2020, some of you might remember what happened in 2004. There was a tsunami which killed almost 2.3 lakhs of people. In 2005, there was very heavy rainfall in Mumbai in India, with an estimated death of around 1,100 people. In 2013, there was a cloud burst or a heavy rain in Kedarnath, which killed around 5,000 people. Yeah, recently, although last year also there was a cloud burst somewhere. And 2015 in Chennai, 18 in all India level, there was a heat wave. 2018, there was heavy rainfall in Kerala, 500 people dead. 2019 also we had Maharashtra, Kerala, Madhya Pradesh had some flood. And 2020, some heavy rainfalls and floods in Hyderabad. Why I am telling all these things is, you must understand that these things are increasing every day, and it is going to increase in the coming year. And if you see that 2020 alone, there are a lot of red balls and green balls and the blue balls here. Red indicates that it was temperature was high. If you take that Asia, July 2020 was the Asia's 3rd warmest year. If you go to North America had its 2nd warmest July in record. So in 2020, you can see a lot of these red balls. That means temperature has gone up in almost all the parts of the world. And in Bangladesh, there was heavy rain, this green ball. And also in the Arctic Sea, there was heavy melting of ice. So many things are happening across the world, like flood or temperature rise or even drought, because of this change in our climate. So why this change in our climate is happening? One reason is called the global warming. And the reason for the global, I'll just show you one graph. You can see this, no? There are some pink arrows coming and the blue arrows. Can you see this slide?
Yes, sir.
So you can call this pink one as sunlight or solar energy. And the blue ones you can call as earth light. I'm just calling it as earth light. If energy coming from sun is called as sunlight, energy going out of the earth can call as an earth light. Actually, if you want to live on this earth, there should be a balance between the energy coming from the sun and the energy going out of the earth. If the entire energy that is going back, then we cannot live in this world. So there should be some kind of energy that is remaining on the earth. But you can see the circle on the right side where I have marked, which shows that 350 watts per meter square of energy is going out of the earth. And some of them are coming back. 324 is coming back, hitting the clouds or some gases on the atmosphere. This is what is causing the earth to warm up. If more and more energy is coming back to the earth, then naturally the earth will get hot. No, as we gave an example that if you have air conditioners installed everywhere in your city, then the amount of heat that is rejected by the air conditioner will actually heat up the entire area. Similar to that, we can see that there are some earth light coming out of the earth. And if some of them are coming back again, that will heat the earth. This is a very simple way of explaining what is a global warming. And as and when the greenhouse gases or the amount of some gases like carbon dioxide, methane, or nitrous oxide increases in the atmosphere, then amount of heat coming back to the earth will also be more. So earth will get more and more warmer. That is the simple thing. If you see that there are many, right side, there is the greenhouse gases. Carbon dioxide is the most important greenhouse gases, 65% of them. It is produced whenever we burn fossil fuel like petrol, diesel, coal, natural gas for any purpose. And there is methane. As I said, methane is coming out of, there is a natural process where methane is coming out from the catchment area of the dams. Methane is coming out. When any plants decay, methane is coming out. So these things that methane, nitrous oxide, carbon dioxide, and creates, and some of you told about the chlorofluorocarbons. No? There are some other gases also which creates this an envelope on top of the earth, and that reflects back some of the energy. And if you look into what are the processes, whenever we convert electricity to produce 25% of this greenhouse gases are produced for electricity, where we are actually enjoying this light and fan. And agriculture and forestry and other land use produces around 24% of this greenhouse gases. Transportation, whenever we drive a car or a vehicle, it creates some kind of greenhouse gases, almost 14%. Industry that is running around, working around us produces 21%. So different, what I said, when I started this presentation, I said that human beings, by converting energy from one form to another, create a problem to the climate. This is how we create. When we produce electricity, when we produce, when we travel, when we build buildings, when there's industries are working, all these energies are converted from one form to another, creating greenhouse gas emissions and also heating the entire world, which is called a global warming. So quite often I've seen that whenever you talk about global warming, people talk about ozone layer depletion also. You must understand that both of them are different. Whenever people talking about global warming, they say or talk about ozone layer depletion. Ozone layer depletion, as you can see on the right side, there is a graph which shows that there is an ozone layer on top in our atmosphere, that blue one, which is getting depleted because of the chlorofluorocarbons. One of your students said that the problem of chlorofluorocarbons is that whenever that is there in the atmosphere, it eats away this ozone layer, and ozone layer actually protects us from the ultraviolet rays coming from the sun. So when there is a gap here, when it is eaten away, this ultraviolet rays will come and hit the atmosphere. It is nothing to do with global warming. Global warming is what I said a little bit ago. When the sun solar energy is coming up and earth light, sunlight is coming, earth light is going out, but some of the earth light is coming back again from the atmosphere because of carbon dioxide and other gases. As it comes back and back and back, the earth gets warming. So don't just get confused with ozone layer depletion and global warming. Both of them are different. Ozone layer depletion causes ultraviolet rays to come into the earth, and carbon dioxide and other greenhouse gases causes the earth to get warmed up. Is that clear?
Yes, sir.
Okay.
Yes, sir.
Now
Yes,
let's
sir.
talk a little bit about the oceans, because today is the World Oceans Day. You must learn two terms here called El Nino and La Nina. El Nino is a little boy. It means, in Spanish, it means little boy or Christ child. In Spanish, it is called Christ child. It is a period of unusually warm water in Pacific Ocean. You know, you have learned about different oceans here: Indian Ocean, Arabic Ocean, then Bengal. There are many Pacific Ocean, Atlantic. And in the Pacific Ocean, when there is an unusually warm water coming up, which is called El Nino, it will not happen every time. It happens once in a cycle. Then La Nina is just the opposite, as a little boy and little girl. La Nina is a simpler cold event. So whenever there is these kind of events happening, this is an extended view of the world. You can see a lot of arrows moving here and there from one form to another. You can see here in India, monsoon. This is the movement of water and air across the world. And you know that air moves from one point to another point when there is a difference in temperature. Similar, water also moves from one place to another because of difference in temperature. And the most important thing that we have to understand is that 93% of the heat that is generated, what we said about the global warming, is absorbed by oceans. 93% of the heat accumulated in the Earth's atmosphere is absorbed by the ocean. So this ocean is getting warmed up. The recent studies say that the Arabian Ocean is warmed up by around 1.2 degrees centigrade in the recent time, and similar to the Indian Ocean also getting warmed up. So when because of global warming, the ocean gets warmed up. So you will have this ocean currents changing, although the movement of air changing. Because of that, we have this tornadoes and hurricanes coming and hitting us every time. And warming sea hurts not just us, it hits the marine life. It makes stronger storms, and warming seas drive sea level higher. The sea level is also going up and up. One calculation shows that from 1900, the sea level has gone up by 20 centimeters. 20 centimeters. That is, it's a very significant level, especially for a country like India or from place like Kerala, where there's a long coastal area where India is surrounded by sea on the three parts of it. When the sea level rises, some places will go under the sea. So in the last 120 years, the sea level has gone up by around 20 centimeters, mainly because of ocean expansion because of the global warming. So, let me go a little bit faster. I'm talking to you about the young minds like you. I'm very sorry to say that sometimes we old people are not ready to listen to you people. Whenever you say something, we say, oh, they are very young. We are very old. We know everything. No, actually, we old people have created all these problems. And a couple of young people came up and asked this. I know you must have seen this girl on the left. Who is this?
Greta Thunberg.
Yeah, Greta Thunberg. And just read that. Anybody knows the name of the girl on the right? Anyone? Okay, I'll give that name. And today when you go back home, actually you have to search in YouTube and listen to her speech, both of them, Greta and as well as that girl, I'll tell the name later. Greta said that we will not let you get away with this. Right here, right now is where we draw the line. She said, I am going to draw the line. The world is waking up and the change is coming, whether you like it or not. She said that to people like me, the old people like me. Normally what happens in your house, the father and mother draws the line and say the children, you should not go out of this line. But here, these young minds, people like Greta, you also should think about said that you have already destroyed this world quite a lot, and I am not, or we are not going to allow.
So can you say the name of the lady on
the right? Yeah, her name is Savern Suzuki. She is not a lady, she is a 12-year-old girl. I know maybe she must be younger than many of you who are sitting here. When she went and spoke in the UN Earth Summit in 1992, 30 years back, the first Earth Summit happened in Rio de Janeiro. And she gave a wonderful speech of around 7 minutes, just like what Greta gave in UN last year. And she said that if you don't know how to fix it, please stop breaking it. I challenge you, please make your actions reflect your words. She said this to the world leaders, say that I challenge you, please make your actions reflect your words. Don't just talk about these things, but show something. And we are yet to listen to these young minds, and many people like you are still here who will ask us, why did you destroy this world? And for making us every year, you can see that every year it is getting warmer and warmer. There is all these hurricanes and tornadoes, and all these things are because of this, our generation, which used energy extensively, unscrupulously, destroyed the forests, destroyed the ecosystems. And because of that, actually, many of us, and probably in your future, you are also suffering. So we must listen to these young minds. Listen to the name Greta, you know, but listen to Savern Suzuki. She went and made a speech in UN when she was just 12 years old. Now, let me come a little bit to our own house. What I'm showing you here is the energy sources in your house. On the left side, one electricity is an energy source by which you can work your washing machine, mixie, your iron box, your whatnot, the fan, the TV, and computers. And there are two cylinders here. On the green one, anybody can identify what is this green one?
Biogas.
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 Great, excellent. And the bottom one is called the LPG.
Biogas.
No?
LPG.
LPG. It is liquefied petroleum gas. And the right side,
LPG.
there is a petrol pump. I'll show that diesel and petrol. No? So these are or compressed. These are the main energy sources in your house. Don't think that electricity is the only source. I have a question to you. Which is the form of energy that is giving you maximum capacity to do the work in your house? Or you said that energy is the capacity to do the work. Muscular energy is there. Yeah, excellent. Yeah. We fight with each other. No, you kick your brother or son, daughter with your muscular energy. So I forgot to talk about that. Okay, great. And your father and mother or whoever works in the kitchen, everybody, they use lots of human muscular energy. But I'm just talking about this main sources of energy, which we convert from one form to another to make our life comfortable. So these are the main sources. If somebody asks you about what are the sources of energy in your house, just don't limit yourself saying that electricity and LPG. There are many other sources like muscular energy or even the petrol and diesel and biogas. I have a question. Just look at this slide. How many of you can answer this? How much electricity is consumed in your house this month or in the last month, May? How many of you have looked into your electricity bill? Or how many of your parents have shown you the electricity bill? I want to know not the money part, but I want to know about the kilowatt hour or the, that unit of electricity is kWh. Note that how it is written. K is in small letters because small k is kilo. W is in capital letter because it represents watt. And H is in small letter, which is called hour or time. kWh is the unit of electricity. How many of you, if you have not, today this is an assignment for you. After completion of this class, go and ask your parents to show the electricity bill and find out what is the units of electricity you have consumed last month.
10,000 or 11,000?
10,000 units per month? Need not, no. I think it can't be more than 200 or 300 units per month. 10,000 is very high, but still, it's okay. But you gave an answer. That is perfect. Pardon?
Sir, I mean per year.
365 units of energy.
Oh, 365. Great. What was that bill amount? 130 units. Great. Yeah, that's a good. It's good that you know about it. And how many cylinders of LPG you use in a month?
2,500 rupees.
So one.
2,500 rupees for how many units?
365.
365. Okay, great. Somebody said 130 units, no? What was your bill amount? Okay, great. I paid last month. Actually, this is a in KSAB or the electricity board gives you a bi-monthly bill, no? It is for 2 months, not for 1 month. Last bill, I paid 850 rupees for my house for 2 months. That means it's around 425 rupees per month. For me, the bill amount was that. And around 120 units per month was my consumption. So somebody was telling 130, it's closer to that. And next question is, how many cylinders of LPG that you normally use in a month? You can ask your...
2 cylinders, sir.
Oh,
2 cylinders. 1 to 2, sir.
every month. Yeah.
1 to 2, sir.
Yeah, 1 to 2. Sometimes you use 1, some people use 2. And those who have motorbikes or car in your house, ask them, the people who are using it. I'm sure you will not be using it, most of them. Ask your parents, ask your brother, ask your sister using how much liters of petrol you consume. Why I'm asking this is, I want to find out the biggest energy source and how much you pay for that in your house. This is an assignment for you. Today, petrol. Petrol. The biggest energy source is petrol, you said, no?
Sorry, its price is so high.
Okay, so let me ask you one question. You said petrol. Whether 100 units of electricity or 20 liters of petrol is giving you more energy? Do you know? I think there is some crosstalk. Somebody who is not actually answering the questions, can you please mute? My question is whether one cylinder of LPG or 130 units of electricity or 20 liters of petrol gives you more energy.
So electricity.
How do you know? These are in 3 different units, no? It is like asking whether 10 mangoes or 100 jackfruit or anything like that, no? There are different units it is there. One is in kilogram, one is in cylinders, one is in kWs, one is in liters. So what is the best way to understand which is maximum? You have to convert that into a common unit, no? Am I right? Unless you convert that into a common unit, you will not know. So I'm just giving you a clue. One cylinder of LPG is 165 kilowatt hour, or 165, it is equivalent to 165 electrical energy units. And 1 liter of petrol or diesel, approximately, it's around 10 units of electricity. So,
petrol and diesel. Petrol.
So now you do think, take a pen and paper, and just write, even if it is not correct, it's okay. Just write how much electricity you consumed in your house. Suppose somebody said 350, no? Who said 350 units?
For me.
Yeah, okay. So for you, your electricity consumption is 350 kilowatt hour, no? And you use 2 cylinders of LPG in your house per month. Then 165 into 2, how much it is?
Sir, 320.
330. 320. 330.
30.
330.
Yeah, 330. So for him, he used 350 units of electricity and 330 units equivalent of LPG. And let me say that he used 40 liters of petrol. That means it is 400. 40 into 10 is 400, no? In that case, you can say that petrol gave him maximum energy. This is, I am just giving you an example. I will show you one table. This is a study where I did. That particular house had 100 units of electricity per month. So that means it is 100 kilowatt hour, and they pay 500 rupees per month. And they use only 1 cylinder of LPG in a month, which is equivalent to 165 units or 700 or 800 rupees. And they had 25 liters of petrol, which is equivalent to 250 units and pay 2000 rupees. So that means in this house, they consume maximum energy for traveling. That is for their petrol and diesel. And they pay maximum money for petrol and diesel. But this I came to understand only because I made this calculation. Otherwise, majority of the people will think that they consume maximum energy for electricity or maximum energy for cooking or something like that. So this is your assignment. Today, you go and ask your parents, what was your electricity bill? Note down that kilowatt hour and ask them how many days the LPG cylinder will last. If there is 1 cylinder, you take it as 165. If it is 2 cylinder, take double. If it is half a cylinder, just make it half. And ask them how much petrol and diesel, multiply by 10 and find out where you use maximum energy, and also ask them the cost and find where you find maximum. This is what is called an energy auditing. So you have become an energy auditor by now. I have trained you to become an energy auditor. So great going, you can tell. And I'll stop with another couple of slides. This is how to, we were talking about how to use energy in the most efficient way. No? So this graph shows that in the lighting, this green one is called urban and the blue one is rural. Maximum 100%, majority of the people are using energy efficient lighting like LEDs in your house. But the next one is shown the fan. Energy efficient fans are used in a very less way in our India, across the India. And this fan consumes actually maximum energy in your house if you calculate. I'm not going to those details, but just to give you that these are the things: lighting, fan, TV, refrigerator, washing machine, water heater. You have to find out how efficient they are. This is we can learn this if we have another opportunity to meet. It takes some more time to learn, but just to understand, now we have learned where you consume maximum energy and where you pay maximum cost for that energy. And this is an assignment for you. You can do it today. And I'm going to close this by asking you what one important thing that you can see around your house. I can see majority of my houses near me, my neighbors always burn these leaves and paper and everything every day, creating a lot of pollution. It is, what I want to tell you is, it is not just whenever somebody is burning leaf, no, you have to go and tell them, sir, these leaves are actually captured this carbon dioxide from the atmosphere, and it is saving us from global warming. And actually trees absorb all this carbon dioxide and convert and store it under the sea. And when we burn it by just using a matchstick, you release all this carbon dioxide in the atmosphere and heating the earth. So one reason that we have to say that you should not burn leaves. You can just put it under the soil, make it will naturally decay and it become very good. But whenever your father, mother, or your neighbor burn these leaves, tell them you are doing a damage to the earth. Just like Greta said, I am going to draw the line here. You should not burn these things. And it also happens with the governments also. Sometimes they say that waste to energy. A lot of waste is collected from our house by different things. And they say that we are going to make energy from this. You can also tell them, no, 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 waste to energy is the last step. Before that, you have to see how you can prevent this waste. You have to minimize the waste in your house also. You have to reuse whatever that is possible. You can recycle, just like you are using a pen nowadays. Instead of changing the refill, we are actually throwing the pen out of your house. We can reuse it. We can minimize it. Whenever going to a shop, use a cloth bag instead of a plastic bag so that you can prevent it. You can minimize the waste coming up. So always think that creating energy from waste is the last step, but biogas is one thing that you can use in your house for creating energy instead of throwing it out. And I want to tell you that whenever you see somebody burning leaves in your neighborhood or in your house, tell them, actually, we are creating a lot of damage to the earth. What is the time now? How much more time?
The time is 8 o'clock.
8 to
8. Okay. So I'll just run through some of the new energy sources and stop it. I'll take just 5 minutes. There is something called a fuel cell, which is going to be a very important fuel energy source in the future. It is like a battery where hydrogen and oxygen are the fuels and water is the output. So there is no pollution coming from these fuel cells. Many researches are going on. There are many vehicles running in many developed countries using these fuel cells. You will learn about this, but just to understand that fuel cell is one of the future energy sources. Then another thing that we are using is solar energy. Solar energy can be used in two ways. One is for using the heat of the sun, which is to heat water. It is a solar thermal energy or solar thermal water heaters. It can be different types. One is called a flat plate collector or evacuated tubes. And in deserts like Rajasthan, you can see big antennas are kept, which absorbs a lot of heat and convert that into different types of energy. And solar energy can be directly converted to electricity, which is called a solar PV or solar photovoltaic. PV stands for photovoltaic. And there are two types of solar photovoltaic system. One is called a standalone system, that you have a solar panel on your house and use entire electricity for your house, use a battery to charge as a backup. And there is something called a grid connected solar energy, where you don't require a battery. Whatever energy that you create by creating a solar rooftop on your house, some part is used in your house and some part is given back to the electricity board or whoever that utilities providers. And if you generate more electricity, you can give maximum more to the electricity board. And solar electricity can be used as for solar pumps, directly pumping water in areas where no electricity is there. And there are many biofuels, as I said in the beginning. Corn, you can generate biofuels from corn, you can generate biofuels from sugarcane. And this is another graph of biogas plant, which we have already seen. I'm just going to it. And there are potential of creating energy from small, mini, and micro hydro plants. I said hydroelectricity is creating some problem, but when you go for a small and micro, the problems are less. But I'm not saying that everywhere this is possible, but compared to the large dams, in places like Kerala, where you have around 44 rivers, this is a better option than creating a big dam. A small and micro hydroelectric plant can be thought of. And there are wind turbines available. All these are renewable energy sources. Different types of wind turbines are there. And that is it. I'll stop my presentation. You can ask some questions. And after that, probably you can go to that quiz. Matthew, sir, can we have around 5 minutes for some question answers?
Only 5 minutes. It's already, normally we will stop at 7:45.
Oh, is it? Oh, sorry.
So we
That's
want to 5 minutes only.
Okay.
Or else they can send questions and we can send answers to them.
Sure. Sorry that I was not really keeping a watch on the time.
Sir?
Yeah.
Sir, I'm Lakshmi Sujita, sir.
Yes, tell Lakshmi.
Solar panels in Antarctica regions like Arctic, in ice regions.
You're asking whether we can have solar panels in the Arctic and Antarctic region. Am I right?
Yes, sir.
To produce electricity?
Yes, sir.
For people living there?
Absolutely, sir.
Yeah, you can keep it anywhere, but it is always better to have it on the areas like in Kerala or India, which is on the equatorial region, where you have maximum sunlight coming up. In the Arctic and Antarctic region, you will not have sunlight all the time. The best places for having solar panels is places like in the around the equator, like India, or in the places like in Kerala. But there you have seen in many places where they will not have even sunlight coming in some of the days. They have totally dark sometimes, no? So that's not a, and second thing is people, if you want to convert that and transmit, it is still very costly and viable only when you have too many people living in that area. So it is possible if you have sunlight. Technically it is possible, but whether, as I said, whether it's economically viable, it is good for them, or all those things, we have to calculate and find out. It depends upon how many solar days you have, how much energy you get from the solar sun. And it is maximum energy is coming in the equator area where you get the maximum sunlight.
The email ID is given there. If you have any doubt, you can write in that email ID and we will pass it to Mr. C. Jayaraman and he will write you directly because the shortage of time. My email ID is given there. You write your doubt, questions in that email ID. I will pass the questions to Mr. Jayaraman and he will write you. Is it okay, Jayaraman, sir?
Yeah, sure. Anytime they can call me or send an email, no problem.
Okay. You may kindly contact me in the email ID given in the chat box. Now I call upon Professor Phil Robinson to propose vote of thanks. Immediately then Bishop will say benediction. Then we will have quiz program. Then we will be showing a small video, 5 and 10 minutes, to while you are quiz, and we will be announcing it within 10 minutes. Now, Philip Robinson, kindly unmute.
Yes, sir. So it is my privilege to propose the vote of thanks in the Eve of World Ocean Day special lecture program for the school students. We are very happy that this is the 6th program where we are organizing for the school students. I wholeheartedly thank Honorable Bishop Right Reverend Dr. A.R. Chellaiah, Bishop in Kanyakumari, for inaugural address. Bishop has clearly mentioned the importance of God, man, and nature, where we are giving importance for all the connectivity with God, man, and nature. Definitely, we are very grateful to God for all the creator God for all the benefits what we are receiving every day. We wholeheartedly thank the today's keynote address, today's chief guest delivered the keynote address, Mr. Jayaraman sir, Equinox, and Managing Director, Equinox, for his wonderful and thought-provoking lecture. Sir is a great scholar. We have heard plenty of things from him. I wholeheartedly thank you, sir, for your wonderful talk. Right from the beginning, the wonders of nature you have clearly given. The egg, the cobweb, the cockroach, and even the small creatures have its own significance in nature, where the human, where we are. And you are very clearly given a talk about the energy, X energy, entropy, where you have mentioned the renewable and non-renewable energy right from and up to the biomass energy you have clearly covered. I hope the young minds, especially the today's attendees, the Greta Thunberg and Sawan Suzuki, they come out with a very good impact. Truly, the assignment makes the young generation as a climate resilient community in the forthcoming days. Sir, the talk as well as the discussion, the question what you are posed, it really made our students to think. I hope it will continue in their classes also. Definitely, it will make them, that it will mold them in the forthcoming days. It is a very informative and thought-provoking lecture. We wholeheartedly thank all the teachers who encouraged their students to participate in this wonderful evening program. We thank the teachers for encouraging their students to participate. We thank the ECO directors, especially today. The opening prayer was done by Professor Reverend Vincent Aya. We thank him for his presence and the opening prayer. We wholeheartedly thank the students. Students, we are very thankful to you. Right from the beginning, you are actively participated. You have take part in the discussion. You have answered the questions correctly, and we encourage and we greet the students for their presence. We thank the technical team, and we wholeheartedly thank the pillar of this particular program, the Professor Dr. Matthew Koshi sir and the associate directors for the wonderful arrangement. And once again, we thank you all behind this. Thank you once again.
Now we have posted the question link in the chat box. Now Bishop will say Bishop will say benediction, but we will continue till valuation. So we are closing the official section now, but we will continue for announcing the.
So there is a request from somebody called Aravind. Please send the link again.
The link is there, already published.
Yeah, he's asking to send it again. Okay.
It's already published in the chat box. Then now Bishop will say benediction. After that, you can send the answer, and within 10 minutes we will answer. We will announce the result also.
Okay.
Bishop.
The grace of our Lord Jesus Christ and the love of God and the fellowship of the Holy Spirit be with you all. Good night.
Amen.
Amen.
Okay. So thank you very much. We will meet. Next class for students is on 29th June.